sorry, I'm back. Problem now. We were plugging yes equation into have equation here. We're gonna multiply 5 5, so we get 5x squared minus 0 x times 5x x minus x equals 0, or the coordinates here are 4 equals x, and then we figure out y. That by equations, y equals 4, 5, y equals 5, y equals. There's our. What is the coefficient? This is a binomial expansion problem. This is not going to be. This is also this is a sequence now, and that gets us to that practice. Go to the other one. Um, Be sure we four sets of problems. Did the first one. All of the so from your spreadsheet, said 3 by 3. That is actually a while ago. You let's throw um 3 by 3 matrix. Could think of it as equations, variables wanted to, or we could think of it as matrix where the constant zero. But the point is that help topic said that row reduction. We're just going to practice without worrying about if it's so. First thing I would see is I want to have one in the top left corner, bottom row to the top, and then I'm get rid of other end one. top row, I'm going to add negative bottom row to it. And I'll take row and add negative. Have -2 plus 2, -8 minus 1. Have +4 plus 0 is negative, whereas positive. That's good. +4. +4 plus 0. Now we're going to do -3 plus 3, -12, and +2. I'd like to get a 1 in this position. And a good way to do it. I'm kind of thinking of adding the two rows together to get a 10, maybe dividing by 2. Try that. If I add the two rows together, if I divide by 10, then I if I divide this by 10, 1, or if I divide that row by 1.6, then if I do -7 times this row, that'll get 0, -7 plus 0, -7 times this, get 6 times 7, negative, negative, -11 plus 4 gives us 7. This is not completely row reduced, but we now gone through the forward direction. Forward direction gets in our case rows. At this point, we'll multiply the bottom. We'll divide the bottom row by a -2. 1, 4, 1. We'll now do bottom row times -1.6 plus the middle row to get rid of that. We'll multiply it by 2 to get rid of the 1 on the bottom. 1 times -1.6 plus 0, and there. -2 times 2 times 1 minus 2 there, and then last step, -4 times the middle row plus the top row gives us 0, 0. This is the complete row reduced, which is kind of what we should expect. Because if we're only doing a 3x3 matrix and row reducing, as long as the determinant of this matrix not 0, That means that we have what's called an invertible matrix. If you have an invertible matrix, then you're able to get to. But the point there was to give some practice. Other comment was fraction matrix rate on the test. Throw in some questions like rewrite the logarithmic equation in exponential form. So did some matrix already and practiced adding some. Yeah. Throw some questions. Write the following log. Okay. So logarithm. This is the this is a question that I like to put on. This is a question that I'll probably have time to look at. But what's really fun about logarithms, you have a bunch of logs that are being applied together. Which log has oh, we can take this, rewrite this as well, natural log has to do, so let's put 1 over natural. And log base 2 has, well, 8 is a power of 2 here. And log base 6, well, this hasn't been, it has to go. So I just shuffled around the arguments, that is the insides of the logs. Didn't change any. Moved them. Really neat trick, but 1 over e to the 1 is negative 1. ln in the e 1, leaving. Because the reason we do that is through the change base formula. If I have the log base 5 times the log base 5 of 2, for example, this is the same as the natural log of 5 times the natural log 5 using. I just switch which fraction is. Technically, I could just cancel there, but for the purpose of showing the swapping, change of base formula, log base 5 times the. I've just essentially swapped because I'm able. That's what's going here, except it's in three. It's with 3 logarithms. Goes into this one, goes into that one goes into that one, and we logarithm exponent. I like putting. I do like putting it on the midterm. I like to do the example problem class first, and um, I think that's